So these are the contents for today's presentation about subsystems, and next is use case realization, design concept. First we'll be discussing about what is subsystem. A subsystem is a package stereotyped with a special symbol called as subsystem with arrow bracket. So here what we do is that we take the complete system which we are in need to implement, and then we divide the system into certain modules. Each and every module will be a collection of classes, and such module will be called as subsystem. So there are two different types of subsystems are there. One is called as design subsystem, where you group the systems into modules based on design perspective. And next is called as implementation system. Again, we can redesign the subsystem based on implementation concept. So which all parameters can be grouped together is listed over here. So we can group design classes and interfaces, something called as use case realizations, which we have already discussed, such as sequence diagram, collaboration diagram, etc. That is the interaction perspective. And some other subsystems can also be there within a subsystem. And finally, specification elements, that is requirement specification element, which is nothing but use cases. So these contents can be grouped together to form one complete subsystem. Some of the uses of subsystem. So here, why do we divide our contents or our system into modules? What is the meaning of that? Is that to separate the design concern. So when we treat the complete system together as a whole, it will be very tough for us to concentrate on the design concept. So that is the main advantage for dividing your system into modules, and represent the large grained components into simpler one. So when we divide into subsystems, it will be very easy for us to code it, and also if there is any errors which is present in the components, we can rectify the errors quickly. That is a major advantage. And we can wrap the legacy systems. So the meaning of legacy systems is highly dependent systems or highly dependent components can be wrapped together to form one system, one subsystem, so that the dependency within the subsystem will be higher rather than the dependency between two different subsystems. So design subsystems are how you begin in order to componentize your model. So your model will be considered as a complete model which you can divide into various components. So such type of componentizing your model is done by means of dividing into subsystems. So you can break the analysis package into one or more design subsystems, and also we can introduce design subsystems also. So first what we do is that until this particular session, you have analyzed various classes from the requirement specification, you have modeled everything, and your classes, design classes, everything is ready with you. Now what you do is that you take the analysis classes and then convert them into analysis packages. So during conversion, if you feel some other design components can also be introduced to make it fruitful, you can do that also. That is, you can include design subsystems also. For example, if you wish to add database, access classes or communication classes, etc. So such can be formulated as a separate subsystem. So this is a representation of a subsystem. It will be like a package icon where above which a rectangle symbol, above which a small rectangle symbol will be there. So there using this arrow bracket, you are in need to represent the subsystem. Another representation is that you can use something called as subsystem icon. So that can also be used to represent that database access as a subsystem and business logic is another subsystem. So here we will be discussing more about subsystem icon. So subsystem icon can be divided into one or more compartments. Okay, so usually it will be having three different compartments. In first compartment, we used to represent operations. In second compartment, we used to give the use case realization elements. And third compartment, we used to give you the specification elements, that is requirement specification element. So this is a representation of subsystem. So the name of the subsystem is courses. You can see a subsystem icon which is present over here. And within this particular box, we used to divide into three different compartments. So first one is going to have certain, that is operations. And next we have realization elements, and in third component we have specification element. So in specification we used to give the use cases, and in realization we used to give the particular classes which is going to satisfy this particular use case. And then in operation phase, operation compartment, you used to give the name of the operation with arguments and return time. Next, we'll get into subsystem and interfaces. So in last video session, you people have understood what is interfaces. So this is a recap. Interface is mainly used to hide the complete design and implementation perspective of a system so that the implementer, that is a coding person alone, can view the complete implementation details. Other design person can view only the design components of a system. So we divide implementation concept separately, design concept separately. So to link either, we used to have interfaces between them. So whenever a public class within a subsystem, that is if you take a subsystem, it may have multiple classes inside it. So if there is any public class, okay, so if it is having any realization to the interface, we can say the complete subsystem realizes the interface. So this can diagrammatically shown like this. So customer, order and product are subsystems. And you can see there is a guide, that is a graphical user interfaces, that is again a subsystem. So these a graphical user interface subsystem will have access to customer subsystem. So here we used to represent this by means of interfaces. Next is called as a facade pattern. It is an important concept. So this is similar to that of interface. Here we used to hide the complex system behind well-defined simple interface. This is done by something called as facade pattern. This is mainly used to structure the system into subsystems, which is going to help to reduce the complexity. So how to do this? A common design goal is to minimize the communication dependencies between the subsystem. So as we already know, if you have two different subsystems, we are in need to make the subsystem to be self-dependent, so that the subsystem 1 is very much rarely dependent upon the second subsystem to complete its functionality. Okay, so to do this, to have this particular scenario, to achieve this particular goal, we are in need to introduce a facade object. So what is the meaning of facade object? It is nothing but an interface which is going to hide the complex system behind a well-defined interface. So you can introduce such type of facade object, and we can have a simplified interface before as a front end, and the complete details of the implementation details of the subsystem can be hidden behind it. The physical architecture and layering pattern. So one of the major concept of subsystem can be achieved by means of layering pattern. So what is the meaning of layering pattern? In computer networks, you would have understood something called as the layers. Okay, that is your functionalities of networks are arranged in the form of layers. So if you take the complete, this is my whole system which I am in need to implement. So here what I do is that I divide the particular systems into something called as layers. The advantage of such particular layering is I can group my subsystems into layers like this. So for example, subsystem 1 and subsystem 2 can be present in the lower layer, followed by subsystem 3 and then 4. So meaning of this is that only after completion of subsystem 1 and 2, next I am in need to process 3 and 4. Before processing the next subsystems called as 5 and 6. And also system 1 and 2, that is subsystem 1 and 2 are highly dependent on each other. Okay, so this type of idea of arranging the subsystems in order is done by means of layering pattern. So to make something called as cohesiveness, so subsystem that is 1 and 2 are said to be highly cohesive, but so subsystems 1 and 3 or 2 and 3 are said to be less cohesive. That is, they are less dependent. Managing the coupling between the subsystems. So how to reduce the coupling between the layers? Okay, that is subsystem 1 and 3 is that you can introduce new interfaces wherever you are in need, or else you can repackage the classes into new subsystems. For example, imagine that in this case, if subsystem 1 and 3 are much dependent on each other, then what you can do is that you can remove the system 3, that is subsystem 3 from layer 2, and you can group it here itself. That is called as repackaging the classes into new subsystems, and then this is mainly used to reduce the coupling between the subsystems. What are the advantages and disadvantages of interfaces? So advantages will be we can hide the classes, that is specific implementation of the classes can alone be projected. And we have many different types of implementations. That is, you no need to start implementation as a whole together. You can go for many compartments of implementations. This is going to increase the flexibility and extensibility, and it is going to reduce the number of dependencies between classes, subsystems and components, which is also called as reducing the coupling. What are the drawbacks? So a trade-off between flexibility and complexity will be there. For example, if a system is said to be less complex, it's simple. If a system is said to be very simple, then it will be very tough. That is very tough to be flexible. That is, if I want to add an operation into it, it is very tough to add such that it will become more complex. Okay, so if the system is simple enough, it cannot perform all the operations. The second drawback is that it is more important that a system is correctly modeled than flexibly modeled. So it should be correctly divided actually. That's why even if there is any drawback like flexibility, you can still control it. Why? Because we are in need to correctly model the subsystem. That's why we go for interfaces. The next part of the presentation goes with use case realization with the design component. So already we have discussed about use case realization. The meaning of this is that this is going to reveal about the interaction diagrams. So how a system is going to interact with other systems based on various scenarios. We have already discussed about sequence diagram, collaboration diagram, activity diagram, etc. So all these things will come under use case realization. Now in this class we'll be discussing about use case realization with a design perspective. So how to change the sequence diagram in such a way that the design elements, okay, after design, in design perspective, if you wish to add new classes, if you wish to add new messages or communication between two different use cases or two different classes, that can also be done. So as I already said you, use case realization with the design perspective is a collaboration of design object and classes that realize a use case. So it mainly consists of interaction diagram but in design perspective, that is called as design interaction diagram. And next is class diagram which contains the participating design classes. So interaction diagram, that is design perspective, may be a refinement of the key analysis interaction diagram. So imagine you have already an interaction diagram, that is sequence diagram, which you kept ready after you have completed the analysis phase. Now if you wish to add certain classes, you can refine it, okay, such that it includes the implementation details. Or else, if you are not satisfied with the previous interaction diagram which is obtained by means of analysis classes, you can drop that and you can draw an entirely new diagram which is going to be constructed based on the technical issues that has been raised during the design phase. So here we can see an example. So this is a use case which we have already designed for add course. So this is a use case specification where we first have a register as an actor and then we have some preconditions, flow of events and post conditions. And this is an interaction diagram which is already obtained after analysis phase is over. So this is what you have designed in your lab experiment. So register will be there who is an actor and there is another registration manager. So my idea here is to add a course. Okay, so the message between the first two classes will be add course and just a create message where a new course is created. So the meaning of new will be the course is just now created. So this is what we have obtained after analysis phase. Now after design, if I wish to change the diagram, I can change it. So this is an updated interaction diagram after design phase is completed. You can see registrar, registration manager are the two different classes which is retained. Now here the changes are registration GUI, that is graphical user interface, is a new class which is felt to be most important. That's why I have added this also. And also the database manager. So two new classes are introduced in design perspective. So this is the interaction diagram which has been changed based on the design perspective. So see the messages also. First I'm going to give add course. So which through the guy, that is graphical user interface. When I click OK button, the guy will intimate the registration manager to add the course. Now the manager will create the course called as UML or whatever it is, and then this will be stored in the database manager. And the return messages will be, that is save by means of save course, the database manager stores this information into the database. And then the reply messages will be consecutively given until to the register through the corresponding classes. So you can see the compared to that of the analysis interaction diagram, which is much simple, the design interaction diagram holds much more details, and it is clear cut that the design interaction diagram will give many information in implementation perspective. So thank you for your patient listening. The diagrams has been referred from the book mentioned here. Thank you all.